In this video, we are going to talk about confidence interval, and we will find a confidence interval of a mean when the population standard deviation is given. Okay. Before we start that, let us talk about what is the point estimate. Okay. So one of the goal of the statistics is you collect the sample, because instead of going over the whole population, you collect the sample, okay, and then study about the sample, find out the mean, median, mode, whatever you want to find from the sample, and you apply that outcome from the sample to the whole population. Okay, that's one of the goal of the statistics. Now, so how do we estimate the population mean? To estimate the population mean, what we do is you collect the sample, okay, from the whole big population. You collect the sample and you find out the mean of the sample, find out the mean from this sample, and you use this mean to estimate the population mean mu, because x bar is the mean of the sample and mu is the mean of the population. So if you want to find out the average value of the whole population, you find out the mean and then you use that value to estimate the population mean. Okay, so what do we mean by point estimate? So point estimate is a single numerical value. Okay, a point estimate is a specific numerical value obtained from sample estimate of a parameter. So sample estimate is called statistic, population estimate is called parameter. You have seen these words in chapter 1. Parameter. Okay, to estimate the population parameter, we first find out the sample statistic, and then you apply that, you use that to estimate mu, or the population parameter. For example, sample mean is an estimate for population mean. In fact, the best point estimate of population mean is sample mean. So point estimate actually estimate a single value for the population parameter. Okay, for example, if you want to find out the standard deviation of the population, then you find out the sample standard deviation. Take a sample and find the sample standard deviation, and you use that value to find out to estimate the population standard deviation. Similarly, for the mean, for this population mean mu, to estimate that, you use the sample mean x bar. Okay. Other measures such as median and mode vary more from sample to sample. So the population mean, to find out, to estimate the population mean mu, we use sample mean, and we say that sample mean is the best point estimate for the population mean. So measures of sample called statistic, not statistics. Statistic are used to estimate population measures called parameter. These statistics are called estimator. Okay, so x bar is the estimator for mu, for example. Okay, what are the properties of the good estimator? A good estimator should be an unbiased estimator. What do you mean by unbiased estimator? That is, the expected value or the mean of the estimates obtained from the samples of a given size is equal to the parameter being estimated. So if you want to find out the population mean, let us suppose that you want to estimate the population mean. Okay, to estimate the population mean, what you do is you find out the sampling distribution. So what is the meaning of sampling distribution? You pick one sample. Okay, you pick one sample and find out the mean. You pick another sample, find out the mean. You pick another sample, find out the mean, and so on. So you find out mean from here, mean from here, mean from here, and so on. And you find out the mean of the means. If you find out the mean of the means, if that value is equals to the population mean mu, the mean of the means is equal to the population mean mu, then that is called the unbiased estimator. If the mean of these means is equal to the population mean, that is called unbiased, otherwise it is called biased. Okay, the expected value is basically the mean or the average. Okay, or the mean of the estimates obtained from samples of a given size is equal to the population parameter being estimated. Next is, the estimator should be consistent, meaning that for a consistent estimator, as sample size increases, the value of the estimator approaches to the value of the parameter estimate. If you increase the sample size, the value of the mean you get will be the value of the equal to the value of the population mean. That's why it is consistent. Okay. The another property that needs is the estimator should be relatively efficient estimator. That is, all the statistics that can be used to estimate a parameter, the relatively efficient estimator has the smallest variance. The estimator must have the smallest variance, meaning that if you find out the standard deviation of the x bars, that will have the smallest variance, okay, compared to the other estimator of the parameter. Okay, so we do not focus on the properties much, but what we will do is we will focus on the interval estimate and confidence interval. As we discussed previously, the sample mean is the point estimate because it will give you a value, a specific value for the population mean. But when we estimate the population mean using the sample mean as a point estimate, that value may not be 100% accurate. Why? Because that value may be depend on the samples you pick. Okay, that may not be exactly the same as the population mean. So what will be the better way to say that? What will be the more accurate way to give the estimate for the population mean is give a range of values. Okay, for example, let us say this. An interval estimate of a parameter is an interval or the range of values used to estimate the parameter. For example, the average age of students is between 21.5 and 24 years. If you say that, it is more accurate. Okay, for example, suppose you want to know what is the average age of the students who is taking the statistics class. Okay, suppose that you want to know that, and suppose you pick a sample of students and then you found that x bar from that sample is, let's say, 22 years. Now if you say that all the people who are taking the elementary statistics class have average age 22 years. If you say that, that may not be 100% true, right? Why is that? Because you got this sample mean from the sample you pick. If you pick a different sample, you may get x bar equals to 23, right? You never know, because when you pick the sample, it is affected by so many things. Okay, so this value may not give you 100% accurate estimate for the mean, the population mean. So what we do instead is we will say that the average value of the population mean is between 21.5 and 24 years. If you say that, it is more accurate because it includes many possible values. Okay, and it includes both of these values too. If you say this way, then that is both true, right? So this is what the interval estimate means. Instead of giving a single value for a population parameter, we give a range of values. Okay, that is called the interval estimate. And in this chapter, we will be estimating the intervals for different population parameter. Okay, so this estimate may or may not contain the value of the parameter being estimated. A degree of confidence must be assigned before an interval estimate. For example, we say we are 95% confidence that the mean age is between 21.5 and 24 years. In this chapter, we not only give a range of value for the population parameter estimate, we also give the level of confidence. Okay, we are 95% confidence that the average is between 21.5 and 24 years. Or we'll say 98, we are 98% confidence, we are 99% confidence, we are 90% confidence. We will find out the range depending on what is the level of confidence we want to be. Okay, to estimate the interval. Okay, that's what we will be doing. The confidence interval of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming that a large number of samples are selected and that the estimation process on the same parameter is repeated. What does that means? If you want to estimate the population mean, for example, what you do is you pick a sample of big sample size, find the mean. You pick another sample of another sample size, big sample size, and find the mean of those means. Okay, and you allow the repetition, meaning that when you pick one sample and you replace that sample, meaning that you put that sample again in the population and then pick on it again the sample. So this sample may pick some of these values from that sample. That is okay. Okay, so repetition should be allowed to pick the samples. That's what it says. Okay, so let us talk about the specific confidence interval. For the mean we will do, for the proportion we will do, for the standard deviation, and so on. A confidence interval is a specific interval estimate of a parameter estimated by using the data obtained from a sample and by using the specific confidence level of estimate. Frequently used confidence interval is 90%, 95%, 99%. Okay, let us do 7.1. It says confidence interval for mean mu. You are trying to estimate the interval for population mean using the sample mean. Okay, when sigma is known, when the population standard deviation is known, this is the formula we use. If the population standard deviation is not known, we use slightly different formula. Okay, the formula for 1 minus alpha confidence interval for mean mu is x bar. What is x bar? X bar is the sample mean minus g alpha half times sigma is the population standard deviation over root n is the sample size, and then there is exactly same thing with plus sign in the middle. Okay, now what is g alpha half? G alpha half is the g value corresponding to alpha half right area. Okay, but how do I find out g alpha half? Is negative g alpha half is given by inverse norm. We use inverse norm to find out negative g alpha half or positive g alpha half. Alpha half 0, 1, and sigma is the population standard deviation. What we do is alpha will be given to you, or 1 minus alpha will be given to you. Okay, suppose if you want to find out 90% confidence interval. Okay, for 90% confidence interval, what we do is we write 1 minus alpha equals to 90%. That is 1 minus alpha equals to 0.9. So what do you do for 90% is 1 minus alpha equals to 90% means 0.9. Now add alpha on both sides. You get, and then subtract 0.9. Subtract 0.9. What do you get? You cancel that one. So you get 0.1 equals to alpha. So alpha is 0.1. Okay. So alpha half is 0.05. Whenever the question says 90% confidence interval, that means the middle area is 90%, 0.9. So what is the area on the right side? Will be this area plus that area will be 10%, right? Because the middle area is 90%. Whenever it says 90% confidence interval, 99%, 95%, that means the middle area is that much. Now I want to find out the right and left area from that. Since the outside area is 10%, because the total area is 100%. So that 10% should be divided into 5% here. That means 0.05, right? Because 10% means 0.1. And then 0.05 on the right. 0.05 on the right side. Now, this value, g alpha half, this is on the negative side. 0 is in the middle. Negative side. That's why we write negative g alpha half. This is the positive side. So positive g alpha half. So we need to find out g value for the left area 0.05 and g value for the right area 0.05 as well. But if you are using, we use calculator for that. If you are using TI 83 or 84, what you do inverse norm and then 0.05, because inverse norm needs left area. Okay, but if you are using TI 84 plus CE, you can enter the 0.90 in the and then pick the center area, and then it will give you both values. Okay, but for TI 83 and most of the TI 84 calculator, you need to find out the left area and then enter the left area to find out. For example, for g alpha half, to find out g alpha half, what do? You do inverse norm and then that 0.05. What is 0.05? 0.05 is alpha half. See, negative g alpha half is inverse norm alpha half and then comma 0, 1, which is inverse norm and then 0.05, 0, 1, which will give you negative 1.64. Now to find out the right area of this positive g alpha half value, what you do, what is the left area? Left area is 0.95, right? What you can do is you can do inverse norm 0.9501. It will give you positive 1.64. Okay, so the other value will be positive g alpha half will be 1.64. Negative g alpha half is negative 1.64. Okay, so this is what you find for the 90% confidence interval. what is the g alpha half value for the, because all other this value will be given by question. This value will not be given by question. We need to find out that. Okay, for 90% confidence interval, the g value is positive 1.64 and negative 1.64. The left value is negative 1.64, right value is positive 1.64, and you just plug in that value there. Okay, for 95% confidence interval, the middle area is 95%. So middle area is 95%. So 0 is there. So the middle area is 95%. So this area is 95%. What is the right area? Right area is 1 minus 95% will be 5%, right? 5%, right? That means 0.05. So the outside area is 0.05 here. Okay. The middle area is 95%. So 0.95. So the outside area is basically, the outside area, this red area is total is 5%. So what is the, because this part is, this is negative g alpha half, this is positive g alpha half. So the left area is, how much is this area? Is 0.025, right? Because this is half of the 5%, 2.5%, and there is 0.025, that is 2.5%. Now if you want to find out negative g alpha half, what do? Is inverse norm, and the area left of that is 0.025, so negative 1.96. And if you want to find the positive g alpha half, you just divide by negative 1, or you can do inverse norm and then overall left area is 0.975%. That will give you g alpha half will be 1.96. That's what you'll get, positive. If you get negative here, you'll get positive there. Okay, for 99%, how would that look like? For 99% confidence interval, 0 is here, 99 is in the middle, 0.99. So the outside will be 1%, right? The outside will be 1%. 1% is 0.01, 0.01. So if you half that, that will be the left area, and the other half will go to the right area. G alpha half, this is negative g alpha. What is the half of 0.01? That is 0.005. 005 is on this side, 0.005 is on the other side, right? Now, to find out negative g alpha half, what do? Inverse norm and then left area. 0.005 and then 0, 1. That's what you do. Inverse norm 0.005 and then 0, 1. You will get negative 2.58. So the right g alpha half will be, g alpha half positive will be 2.58. That's what you get. Okay, guys. So the idea is basically, so if the 90% is in the middle, you can compare this with 1 minus alpha. That's what I did. 1 minus alpha is 0.9, and then if you solve for alpha, you'll get 10% outside. So 10% is outside. You can do that way, or what you can do is you can write that percentage in the middle and then set the right and left area, and then the remaining area will be 10%. 1 minus, because the middle is 90%, so the outside will be 10%, and half of the 10% will be on the left side, and the half of the 10% will be on the right hand side. Okay, you do that, and then you use calculator inverse norm. So if you are calculating for mu, if and sigma is given, in that case, this is what you find out. Okay, let us do example number 1. So find the g value corresponding to 98% confidence interval. So 98 is in the middle, 0.98, right? So on the left hand side, there is some that is outside the 98%. So this part and that part is basically 2%, right? 2% is 0.2. Because middle is 98%, means that outside will be a 0.02. I'm sorry, 0.02 is the total outside area. If you take the half of that, then you will get 0.01. So this is 0.01. This is 0.01. You need to find out g value, g alpha half, and this is positive g alpha half. Why did I write alpha half? Because the inside area is 1 minus alpha. So outside area is alpha, but this is alpha half, this is another alpha half. That's why I said alpha half there. Okay. Now how do I find out negative g alpha half? Negative g alpha half will be inverse norm, and then area left of that will be 0.01. That's what you do. And then comma, let me erase that. And if you, after the 0.01 is the area left of negative g alpha half, and then mean is 0, sigma is 1. That's what you do. Okay. Let us use calculator to find out that. So in the calculator, what we do to get the inverse norm is, what you should do is go to the second and then verse. You will see inverse norm in the number 3, right? Hit enter. Okay. If you are using TI-84 plus CE, what you do is you don't have to do anything here. You just enter that 0.98. 0.98. Mu is 0, sigma is 1, and it is center area, right? Because the center value is given, the middle value is given, and then hit enter. Hit enter again. Oh, by the way, you should go to the paste and then hit enter. If you do that, it will give you two values there, left value and the right value. That value and that value are given to you. Both value it gives you. But all of you may not have TI-84 plus CE. So what you should do in that case is, this is what you will get. This is the calculator most of you have. Okay, let me clear that. And go to second verse, go to inverse norm is number 3. And what is the area? You need to always enter left area if you are using TI-84 plus only calculator. If it is not TI-84 plus CE, you need to enter always the area left of that. 0.01, 0.01. And what is the mean? Mean is 0, sigma is 1, because you are finding G value. That's why mean is 0, sigma is 1. And then paste, hit enter. What do you get? You get negative 2.33, right? 326 means 2.33. So you got this value is negative 2.33. And what is the other value? Will be G alpha half. Will be positive 2.33, because it is the symmetric. This curve is symmetric about mu equals to 0. That's why. Whatever value you get here, you just change the sign for the other one. Positive 2.33. So how do I do example number 2? In example 2, you need to find out the G value again. So the middle area is 94%, 0.94, right? So you need to find out this negative G alpha half, and then this positive G alpha half. So alpha half, positive G alpha half. So what is the outside area? 6%, right? 0.06. And if you divide by 2, you will get 0.03. On the left, 0.03. This is 0.03 as well. So to find out negative G alpha half, this is not divided by negative G and then subscript alpha half. Okay. So negative G alpha half will be, basically it will be inverse norm. What is the area left of negative G alpha half? 0.03 and then 0, 1, right? So how do I do that? Is go to the calculator again and then do second verse inverse norm, hit enter. What is the left area? Is 0.03. That's what you do. Okay. And then mu equals to 0, sigma is 1, paste. So negative 1.88. You get the negative G alpha is negative 1.88 and positive G alpha half will be positive 1.88. So this is how you find out the G values in the formula of the confidence interval of the mean when sigma is given. Okay, let us do one example here. Okay, how do I do this example? Let us see that. Consider a population with standard deviation 2. Population standard deviation is denoted by sigma, that is given as 2. If a random sample of 40, n is 40, has mean x bar is 20. What is the base point estimate for the population mean? So for the population mean, the base point estimate is the sample mean, that is 20. Okay, and also find 90% confidence interval for the population mean mu. So you want to find out that for 90% confidence interval. So what is the formula? X bar minus G alpha half times sigma over root n. That is the left bound of the confidence interval. The right bound is x bar plus G alpha half times sigma over root n. That's what the formula I showed you earlier. Okay, what is given? Sigma is given, n is given, x bar is given. What is not given? G alpha half. So to find out the G alpha half, what is the confidence interval? Confidence interval is given as 90%. We need to find out, we need to do that thing to find out G alpha half. Okay, let's do that. So you should do 0 in the middle. 0 is in the middle. 90% means 0.9 in the middle. So the left area and the very right area will be 10%, right? So 10% is 0.10 divided by 2 is 0.05. So this is 0.05. This is 0.05. So how do I find out this negative G alpha half then? Alpha half. So G alpha half. How do I do that? Is negative g alpha half equals to inverse norm and the area left of that 0.05 and then 0, 1. You get negative 0, 1. Okay, negative 1.64. So g alpha half, negative g alpha half is negative 1.64. Positive g alpha half will be positive 1.64. So g alpha half will be 1.64. Okay, so how do I now use those values in the formula? How do I do that? Just plug in 20 minus 1.64 times sigma is 2 over root under 40, n is 40, comma x bar is again 20 plus g alpha half is 1.64 and the sigma is 2 over root under 40. Now use calculator and find out the values. Okay, so how do I do that? Is let me go to the calculator and let me clear everything there. Now what I want to do there is I want to write 20 minus 1.64 times 2 divided by root under 40, square root of 40. That's what you do. Okay, so if you do that, what do you get? You get, let me write down, hit enter, 19.48. So the left number is 19.48. So to find out the right number, you can just copy that, whatever you did. Only the difference is this sign must be plus, right? So what I want to do is second and then enter, will copy everything. And then you move the cursor to the left and then change that sign, okay? So let me do that and then write plus instead of minus and then hit enter. You get 20.52. So 20.52. This is the final answer. So what does that mean? That is the 90% confidence interval is 19.48 through 20.52. We got the sample mean 20, and if you want to be 90% confidence interval about the population mean, if you want to find the 90% confidence interval about the population mean, or if you want to be 90% confident about the population mean, you need to give an interval, that is the population mean falls between 19.48 through 20.52. You can say that way, or you can say we are 90% confident that the population mean is between 19.48 through 20.52. In other way of describing the confidence interval is, if you pick sample and find the mean, if you pick another sample and find the mean, pick another sample and find the mean, 90% of the time or 90% of those samples have mean that falls between these two numbers. That is another way of saying that. Okay, this is how you find out the confidence interval by using the formula. But there is another shortcut way. What is that? We can do all these things using calculator directly. What is that? Let us do that one. Okay, let me clear everything. So to find out the confidence interval of mean when sigma is given, see, confidence interval of mean when sigma is what? Population mean is given. If population mean is not given, we use different way. That is the section 7.3. But if population mean is given to you, then there is a direct shortcut way to find out the confidence interval of mean when sigma is given. So you do stat, okay, and go to the test, okay, and if you scroll down, you will get G interval on number 7. So stat, test, and then number 7. If you do that, you will get, do you have data or the statistic? We don't have data here. We have statistic, meaning the sample values are given there. So the statistic is there. So what you do is go to the right side and then hit enter. So that will change to statistic. What is sigma? Sigma is 2 in our problem, right? What is x bar? X bar is 20. We got x bar is 20. What is n? N is 40, right? Because n is 40 there. N is 40. And what is the confidence level? We got 90%, right? Not 95, 90%. And if you hit calculate, hit enter, you get 19.48 through 20.52. You got that directly. Okay. So again, there are two options. So first, how do you do this? Is stat, and then go to the test. Okay. And then go, not a G test. You should do G interval. When do we use G interval? Is if you are finding the confidence interval for mean, population mean, when sigma or the population standard deviation is given, then you pick that one number 7, that is G interval, hit enter, and there are two options, data or statistic. If the data is given, then you pick data and then enter the data in L1 or L2. But if data is not given, if the statistic like x bar is given, n is given, sigma is given like that, then you go to stats and then enter those values that are given values there. Okay, and then also pick the confidence level. In this case it is 90%, and I pick that and hit enter, calculate, and that's what you get. Okay, so this is what I did, exactly the same thing there, and I got those values. All right, so this is what I got. By the way, it sounds like this is not right, because this is negative 1.64 and positive 1.64, because we found that negative 1.64, so this is not right, but this is right though. We got the same answer there. Okay, in your online homework, you see the homework, like you have to enter like this: the population mean mu falls between 19.48 and 20.52, that way. Okay, so I mentioned that how do I use calculator directly, stat, test, and G interval. If the data is given, you enter the data in stat and then hit enter and then enter the data. And when you go to stat, test, and G interval, you need to pick that L1. I will show you that in the next video. Okay, I will show you one example in the next video. All right guys, thank you.